Hello, my name is Mr. Wilke, and today we're going over the Chapter 13 practice test. If you're in my stats class and you already took the practice test, great, keep going, keep listening. I will give you all the answers, talk about how to do it, answer all your questions that I imagine you have. Clearly nobody else is here because, well, we're all in quarantine still. All right, so if you're just stumbling along to this or you follow me on YouTube for some weird reason that I don't understand, I'll read you the answers. You can hit pause, try to answer them. We'll see how it goes. All right, so let's start with question number one. Number one, a chi-square goodness fit test is used to test whether a six-sided die is fair, i.e. the outcomes are all equally likely. The die is thrown 150 times and the results are recorded. Which member of the chi-square family of curves is used? So, what are we asking about? That's right, degrees of freedom. So, here are the possible answers. A, 149, B, 150, C, 5, D, 6, E, 7. So who remembers how to find degrees of freedom? That's right, on the chi-square goodness fit test, it's n-1. So, we've got to decide, is n 150 or is n 6? Well, is it the counts or the categories? That's right, it's the categories. So to be six-sided die, 5 degrees of freedom. Correct answer is C. Number two, a study of accident records at a large engineering company in England reported the following number of injuries on each shift for 1 year. Morning, 1462, afternoon, 1589, night, 1662. Is there sufficient evidence to say that the numbers of accidents on the three shifts are not the same? Test at the 0.05, 0.01, and 0.001 levels. So those numbers, for those of you who don't have the test in front of them, morning, 1462, afternoon, 1589, night, 1662. So our answer choices are A, there's sufficient evidence at all three levels to say the number of accidents on each shift are not the same. B, there's sufficient evidence at the 0.05 and 0.01 levels, but not the 0.001 level. C, there's sufficient evidence at the 0.05, but not 0.01 or 0.001. D, there's sufficient evidence at 0.001, but not at the 0.01 or 0.05. E, there's insufficient evidence at any of these levels. All right, so if you're working the question out now, what should we be doing? We should put these in our calculator, right? So, putting them in our lists. In list 1, I put in 1462, 1589, 1662. In list 2, I've got 1571, 1571, 1571. Can anyone tell me, why do I have that? That's right, those are the expected counts. How did you get the expected counts? Exactly, good. By averaging the three observed counts together, we were able to find the expected for each, if they're all the same, would be 1571. Okay, so now we run a chi-square goodness fit test. We hit stat, go over to tests, go to the chi-square goodness fit test, which is right there. L1, L2, degrees of freedom is 2. Calculate. Chi-square is 13.04. The p-value is 0.00147. So the p-value is below 0.05, below 0.01, but it's above 0.001. So we would reject at 0.05 and 0.01. We'd fail to reject at 0.001. The correct answer is B. Well done. All right. Number 3. Well, it says the next set of questions refers to the following situation. A study was conducted to determine if the fatality rate depends on the size of the automobile. The analysis of accidents is as follows. So here we go. And let's see what the question says. Number 3, under a suitable null hypothesis, the expected frequency for the cell corresponding to fatal type of accident and small size automobile is what? So we look at row total, times column total, row total times column total over table total, right? This is the cell we're looking at, right? Small fatality occurred. So we want 129 is the row total times 93 the column total divided by the table total, 362. And if we work that out, what do we get? 33.141 is correct. A. Good job. All right, number 4, which of the following is not correct? So we're still looking at this. Which of the following is not correct? The null hypothesis is that there is no association between fatality status and size of the automobile. Is that true? Well, this is a association independence. Should be, null should be, there's no association. So A is correct. So we don't circle it, right? We're asking for which of the following is not correct. B, if at least 5 expected cell counts are greater than 5, then the distribution of the test statistic is an approximate chi-square distribution. That's true, right? Good, okay. C, the accidents were cross-classified by size of automobile and fatality status. Each accident was counted in one and only one cell. Yes. D, if we reject the null hypothesis, then we have no evidence to show that the size of the automobile affects the chance of fatality. Wait a minute, the null hypothesis was, what was it? That there was no association. So if we reject the null, we're saying there is an association. So D should be the correct answer as the one that's not correct. Let's find out for sure. E, the alternative hypothesis is that the fatality status is associated with the size of the automobile. That would be correct. So D is the one that's not correct. Number 4, we should have answered D. All right, that's it for the multiple choice. Does anybody have any questions? All right, in that case, let's look at number 5. And let's get rid of this real quick. Magic of editing. And look, the board's clear. All right, so let's look at number 5. Number 5 was the free response problem. This says, answer completely but be concise, write sequentially, show all steps. We're doing 4-step inference. You better have step 1, step 2, step 3, step 4. All right, let's look at number 5 again. Number 5. We could edit that out, but we're not going to bother. In an experiment on what influences opinions, students were asked whether they agree or disagree with the following statement. I hold that a little rebellion now and then is a good thing and is necessary in the political world as storms are in the physical. All right, who said that? I don't know. Clearly it was either Jefferson or Lennon. Jefferson, owner of Jefferson Cleaners. Lennon, lead singer of the Beatles. Thomas Jefferson. One group was told Thomas Jefferson said this. A second group was told Lenin, Vladimir Lenin. Yeah, that guy. Okay, so does it influence your opinion? Maybe you feel better about one or the other. Maybe the students did. Maybe they didn't. Maybe it's just due to chance. That's what we're here to find out. So we want to know whether there's good evidence the source of the quotation influences whether students agree with it. Use a chi-square test for homogeneity of populations to assess the significance of the effect. So, step 1, what do we want to know? We want to know if the two populations are different. So step 1, right? And you should always say what they are. One is, let's say 1 is Jefferson, 2 is Lenin, or I could write P sub J equals P sub L. But also say what you're doing. We want to know, does the source of the quote influence how you feel about it? P1 equals P2, H naught, HA. All right, step 2. Step 2 is always conditions. So, was it random? I don't know. It says, in an experiment on what influences opinion, students were asked. So I would assume the students were chosen at random, or students were randomized something. We don't know, but let's assume that it was an experiment. They probably did it correctly. Are all expected counts at least 1? Yes. Do all expected counts here have to be at least 5? Yes, they do, because only 20% could be 5 or less than 5, and here we've got 4. So all of them have to be greater than 5. So I would say, we don't know if it's random, but we assume since it's an experiment, I would say all expected counts greater than 1, all expected counts greater than 5. We proceed with the chi-square test for homogeny of populations. Not Harry Potter, not hit points. Homogeny populations, not Hewlett-Packard. All right, step 3. This is where we do our math. Okay, so it's observed, right? Sum of observed minus expected squared over expected. Same over here. I don't know what the expected are, but once I figure out the chi-square statistic, that'll do it for me. Okay, so let's run the test. Does anyone remember how to run the test? What do we hit? We hit stat. Stat. Go over to tests. It's the chi-square test. This one doesn't say GOF. It doesn't say HP, but we know HP and AI are done the same way, so we just hit chi-square test. That's C. Observed in A, expected in B. Do I have to do the expected? No, it does it for me. So calculate chi-square equals 7.49967, so let's just call that 7.5. How many degrees of freedom do we have? Well, this says 1, so clearly it's 1. Can anybody tell me why there's 1? That's right, because row 1 minus 1 times columns minus 1. 2 minus 1 is 1, 2 minus 1 is 1, 1 times 1 is 1. And the p-value is 0.00617. Now, if you want to fill in the rest of your work, go to your matrix. Look at matrix B. And there it is. 79 minus 71 point, we'll call that 15 over 71.15 over here. Call this 21.15 over 21.15. Add all of them up. There we go. 7.5 degrees of freedom, p-value. Step 4. What can you tell me about our p-value? Is it high or low? Well, it's less than alpha is 0.05. It's less than alpha is 0.01. This didn't give us an alpha, but those are the standards. So let's say since our p-value is low, we reject H naught in favor of HA. And then we need to put this interpreted in context. So how do we do that? Well, what was H naught? H naught was that they were the same. So we've got evidence to show they're not the same. So there's statistical evidence to show that the source of the quote does make a difference in whether or not somebody agrees with it. And that's it. Anybody have any questions? No? Sounds good. All right, thanks, guys.